An example of a problem you could expect to have on your test for Newton's laws. Table, no friction, 2 masses on the table and 1 mass hanging off of a pulley. Okay, here's how you do it. The gravity is pulling the hanging mass. There's no friction on either of these blocks. Gravity also pulls on them, but the normal force balances out those gravities. So they equal to 0. These two tensions in the A space equal out. Positive, negative, equal to 0. And in the B space you have positive, negative, those would equal to 0 as well. So the net force on the whole system, just 120. I wouldn't give you friction if there are 2 masses on the table. If there was 1, I might give you friction here. I might say there's 40 newtons of friction here. And then you would have negative 40 and 120 and you'd add those together to get the net force. But there's no friction here. So this is the net force. So we put it up here. And because that's the net force on the whole system, we divide by the total mass. That gives us the acceleration. So we get it here. That's the big number. That's what's the same for the whole system as it is for each individual block. Okay, the net forces will be different on each individual block, but the acceleration is the same. So then we pick a block. You could pick any block. But I picked this one because it's the easiest. Because there's no friction. So the only force producing the net force on the 8 kilo block is this tension force here. So we just did the 8 kilos times the acceleration, which we calculated before. And we get that net force. Because on the 8 there's only tension, so this is, you could say this is FTA. That would be in the positive direction, and this one would be negative FTA because it's pulling backwards. This one you could say is FTB, and this would be negative FTB. So tension forces at A and tension forces at B. For the 8, you really only have the FTA pulling it forward, and that's it. There's gravity, but there's also normal, so they add to 0. And so this net force is the tension force at A. Okay, so now you've got that tension here at A. This is A and this is B. I went to the 12 kilo block. You can also go to the 12 and put in this FTA and check and solve for FTB, but I did this one because we know the gravity there. It made sense to me. First we find the net force on that individual block. So just the mass times acceleration again, we get the net force. And then of course the net force is also the sum of all the forces on that block. That block is gravity and tension. We know the gravity, so we subtract the gravity over and we just calculate for the tension. In this case it turns out negative. And that makes sense because on this block the tension is pulling backwards. Okay, so if you're writing a test, you get to here, move on to the next thing. If you get time at the end, you come back to it and go, I should check these numbers, see if they're right. So we're going to use the other block to check it. So we say, okay, let's look at that middle block. It really just has tension pulling on it. It does have gravity, but the normal force cancels it out. So let's check that those two tension forces actually equal the net force on that block. So you go, okay, the net force on this block is the tension A and the tension B. You add those together. And on the 21, the A tension is pulling backwards, so it's negative. And the B tension is pulling forwards, so it's positive. So we add those up and we get this number. And then the net force on this block should also be its mass times its acceleration. And so you do 21 times acceleration and we get very close. Just a little bit of rounding error. And so if you get close like that, you go, good. Two tensions on each side are the same and we're golden. Thank you for your plan.